Okay, today we're going to be talking about exponential growth. We're going to talk about how it grows, different from linear functions. We're going to talk about what the graphs look like, how you can write rules using algebra, and what situations are exponential. You should have already set up in your notebook 4 columns to write this information down as you listen. So we started looking at exponential growth with the ideas of population growth of our bunnies. I showed you here case 2, in which we started with 10, and then each pair had a pair of bunnies each month. So if you can look at it, you'll notice that we have it growing by multiplying by 2 over and over and over again. So we started with 10 and we're multiplying by 2 over and over and over again. In case 4, we started with 2, and each bunny pair had 6, and so the first month there'd be 8 total, and then that 8 would have a total of 24 more, etc. So you'll notice that the multiplier is times 4. It's growing by 4 times 4 each time. So exponential growth happens with multiplying the same number over and over and over again. In this case, it would be 2 times 4 to the x. Exponential growth can also happen when you multiply by a number less than 1 or dividing by the same number. And that kind of growth is called decay. So let's say I had 100 cookies, and each day I eat half or give half away. So after the first day, I would have 50 cookies left, and after the second day, I'd have 25 cookies left, and the third day, I'd start to have to break things in half, and I have 12.5. So then population decay is also exponential because we're growing by either, you can think about it as dividing by the same number over and over again, like dividing by 2, or multiplying by a half or 0.5. So over and over and over again. Once again, the equation is not something we're working on from the we don't have to master it quite yet, but the equation's pretty simple too. You're going to start with your initial amount, and then what is your multiplier? In this case, it's 0.5 to the x power. Exponential growth looks like a curve, and it's an upward facing curve when the multiplier is greater than 1. So if you're multiplying by 1.5 or 2 or 3, it's going to be an upward facing curve. So a curve, an exponential decay curve, is going to go down when the number you're multiplying by is between 0 and 1. So in this particular case, we have 0, 10, and we have 1, 5, and we have 2, 2.5, etc. So this one's dropping by dividing by 2 as well, or multiplying by 1/2 like the one before it. And notice it's going to be a downward facing curve, just so we can get used to writing it, not a requirement right now. This one starts at 10, and its multiplier is 1/2, and the x stands for the number of days or months that this is dropping. So for us, we are going to if you look up exponential growth or decay on the internet, you're going to find this basic equation. But we are going to use it slightly different. We're a mathematical community, we get to do that. And we're going to use a times r to the x, where a stands for your initial amount and r stands for the multiplier. I don't like to use b because b stands for the y-intercept in a linear function. It's just confusing to make it something else. So A is going to be your initial amount, R is going to be what you're growing by. And that's it for today.